It's time to start. Thanks for deciding to spend the next 35 minutes with me. I'm trying my best to not let you down. My topic today is interoperability, the key to the success of IoT, and why and how. I'm Jason Ying from Huawei. I'm also the vice chair of the testing working group in OneMTerm. So here, so let's start. So the agenda will be followed by only two parts. The first part is why, the second part is how. So it's quite straightforward. So we all know that IoT is a market that is big enough. We have a lot of vertical domains. We have the infrastructure, we have the device, we have all the applications, and each of them we can say it's worth of billions and billions of dollars, as we can see from many of the consulting white papers. But we can also say that the IoT is not only about marketing; it's also about ecosystem. So it's an ecosystem that is big enough that not only one company can take it. So it's an industry that needs more collaboration than ever. So if we see from the current challenge of the IoT market, we can say it's still very highly fragmented. This is a picture of all the IoT related standards. That is organized into two dimensions. One is from the system to the communication. The other is from the connect market to the sales. We can see that it's quite complicated. And in each of the sale, we can see a lot of different standards and open source projects. And I'm not listing all the proprietary solutions here. They have fierce competition with each other. This is an analysis from IoT Analytics. So here is the number of IoT platforms for each year. So we can see it's still growing. In 2012, it's 260, but in this year, it's about 450. So this is only about the product of IoT platform. It's not counting the devices and the other business solutions. So we can see that is an elephant. But this is an elephant that cannot be eaten by a single company. So I can say this is a market that needs more cooperation than ever. But where's the contradiction? So if we come with the above set challenge, we always say, okay, we have a standard and we have all the companies to follow the same standard, then this problem will be solved. But diversity is the natural characteristic of IoT. We have companies from different domains, from different businesses. It's really hard for them to talk the same language. It's like what happens in the real world today. Some countries speak Chinese, some countries speak English, speak French, speak German. It's practically very impossible for them to speak the same language. So how to solve this problem? So here we come with the thinking of interoperability. So here's the definition of interoperability from IEC. Basically, it exists several levels. So for the coexist, it's actually two entities stand together. They cannot talk to each other, so they are just coexisting. But if we go to the next level, it's the interconnectable, which means we can share the same communication media, like it's a wire connect, it's wireless connected. Or for example, if we can talk, we need to stand in the same room, and I have the throat, you have the ear, so that we can talk. So this is the interconnectable. And then if we go another level up, which is the interworkable, which means we can share the same, for example, we can share the same language. I speak English, and everyone understands English, so this is interconnectable. If we go another level up, which is interoperable, which means on top of the same language, we need to share the same terminology, we need to share the same information model. Like for example, we are from Eclipse, so we have a lot of terminologies in Eclipse. So when I say Eclipse, you know, it's the open source community. But if we say Eclipse somewhere else, they say, okay, it's the moon that is covered by something else. So this is the key thing, the information model that makes the two systems can work in a plug and play method. They can talk to each other. And then on the top level, which is the interchangeable, so on top of the information models and the semantic ontology we are saying about, the interchangeable is more involved like the dynamic behaviors, like the throughput, the rate, the speed, something like that. If you want to change this device in a system with another device, not only they need to speak the same language, but they need to speak in the same speed so that they can be interchangeable. So I read 2 dots here because these 2 layers are the problems that we need to solve in the open source and open standard area. So this is the key to the interworking that I'm going to talk about today. So here is, this is part of the map of the standards and protocols we can see from the IoT world today that is solving the interoperability problem in different layers. So we can see we have access, most of the standards from IEEE, from Ethernet network, from wireless, and from the network side, we have IP network, we have 6LoWPAN, we have all the others. And then we go to the transport layer, we see the familiar names like TCP, UDP. So from here, we can say this is interconnectable. We can talk to each other. We are physically connected in this way. And then on top of the, for example, HTTP, we go to the we go to the schemas like the XML schema, like the JSON schema. You talk to each other, you understand your payload, you understand content, so then you can interwork. And then if we go another level top, like everything above, you define the information models like in smart home, how do you define a lamp? Like in the smart manufacturing, how do you define a robot? So you need something of this to achieve the interoperability. Now, it's actually everything is about representation. If we divide these devices into very small modularities, we see there in the area network, there will be many devices, and in each device will have applications, and we'll have software, we have hardware, and each of the applications will there have services, will have data points and operation. So this is actually how do we represent the real world hardware services into the digital world. Many of the organizations are doing the same job, like in OSGI, they have OSGI Dell. In OneMTerm, they have everything, and we can see the similar definitions like in OCF and everywhere else. But today I'm going to present OneMTerm because I'm not saying that OneMTerm is defining another standard. I'm presenting OneMTerm because OneMTerm is doing a lot of work on the interworking itself. So OneMTerm is a collaboration standard definition organization that is joint funded by 8 of the regional big SDOs. It have over 200 member companies. The main target of OneMTerm is trying to define a common service in between of each of the silo of the verticals. Then we have a common service that can be shared by different verticals, by different devices, and by different applications so that they can actually talk using the same infrastructure. So the position of OneMTerm is that if we see the overall IoT architecture will have the application, and then it will have the platform, and then with the other gateways and devices. But for the platform itself, it's separating the 2 layers. One is the application enablement platform, and the other is the connected device platform. OneMTerm exactly fitting the application enablement platform because it is providing all the necessary ingredients that can help the devices to talk to each other. So we call them common services. So this is the ecosystem support of OneMTerm. We have a lot of open source projects. We know Eclipse OMTerm in here. And there are some of examples of a commercial implementation. And I will just briefly go to the OneMTerm architecture. So OneMTerm architecture is defining platform, is defining gateway, is defining device, and also applications. So OneMTerm is a RESTful architecture. It defines resources to represent all the services provided by OneMTerm. And these resources are to be addressed by the CRUD, the CRUD operations. So it's a very simple framework. You send the CRUD operations to these resources, then you can enjoy the common services like the registration of application, the management of device. And this is how the OneMTerm is binded to the existing protocols. We are using HTTP, we are using CoAP, and MQTT, and WebSocket. And for the serialization, we are using JSON, XML, and CBOR. So this is how the OneMTerm infrastructure is landed on top of the existing IP network. When I said interoperability, that OneMTerm has done a lot in the interoperability area. That is because OneMTerm is doing a lot of, you can see from this diagram, with the other IoT standards, like in the open source, and in OMA, we have the device management. In IETF, we have all the bindings, CoAP, HTTP, and WebSocket. And also in each of the verticals, like industry, are working on the interoperability with DDS or PCUA Modbus or SGI, which we are working on, and also in the home domain, the e-health domain. So this is the main reason why I'm present OneM today, because this part of the work is exactly how to solve interoperability problem. Because you can see all the lines here. This shows a big diagram of how the interoperability problem can be solved. So this is an overall architecture of how OneMTerm is doing the interworking. So OneMTerm will have several of the resources to represent the devices, applications, and the services. I'm sorry. And then from the two areas of the interworking, one is the we can call it abstraction. It's one-to-one mapping of the services in the physical world, and the other we call it is the semantics. So for semantics, you need to define the ontology, how to understand the real world, so that with semantics and ontology, you can actually do more cool things, like you can do the interference, you can do the mashup, something like that. But mostly, we are focusing on the abstraction world. So you can see all the protocols that we are trying to interworking into OneMTerm resource infrastructure. This is the interworking architecture that we have currently defined. I think you have seen from the presentation from Orange and Deutsche Telekom yesterday about their work of using flex containers and smart device templates. So OneMTerm has defined a resource named the flex container to represent the smart device template that is most regional from the smart home area, so that we can use the resources to represent the temperature sensor, the humidity sensor, and everything else you can think from a smart home. And with these resources represented in OneMTerm architecture, you can access these resources from the application, so that you can have a uniform layer of how to manipulate different protocols from the smart home area. And then these flex container resources will be further mapped to many of the existing smart home protocols, like in ZigBee, Z-Wave, and OCF or Joan, like I have shown in the last page, of how this interworking can be done. And the other one is the OneMTerm based ontology. There's a very close collaboration between OneMTerm and SARF of Etsy. So this OneMTerm is basically defining, you can see from the diagram here, a structure of how to represent a real-world device. So the real-world device is more complex than what we think, because it's not just about sensor, about the actuator. Because they may be representing the actual cars there. So you have a device to represent a car, then you have the sub-device to represent the engine, and then you put annotations onto these the things. Then you can make them correlated by those annotations. And then if you send a query to this whole system, it gives you all the information you need. Not just the direct information, but also the hinted connections that can be interferenced from the semantic connections between the devices. So this is one of the advanced work that OneMTerm is doing. So this diagram is a little bit small from the distance, but basically I'm going to present how OneMTerm is doing the interworking. So there is an entity which is called the IPE. You can see from there, this is the interworking proxy entity. So all this mapping of technologies is implemented and defined in this IPE, and this IPE is responsible for the interworking from the from the NODN. They are simply represented a device. Any of the device, a device of any of the standard or the proprietary device. And CSE is the OneMTerm defined middleware where all the resources is stored. So the IPE is doing the interworking into two directions. One is exposing the non-OneMTerm device services to OneMTerm. So the IPE will have some subscription of the events. We'll maybe round robin the resources and change the data structure to OneMTerm compliant and then store it into the OneMTerm infrastructure. And the other way is that if the resources in the OneMTerm infrastructure is accessed by some request, the IPE will actually convert that request to the other protocol commands, like in ZigBee or Z-Wave, some of the other things, and then send it to the real device. In this way, the interworking is done bidirectionally. So here is an example of what we are doing on this interworking thread in Eclipse. So in Eclipse, we have a lot of OSGI-based open source projects like Eclipse Smart Home, which is an OSGI-based home gateway, and the Eclipse Kura, which is the OSGI-based IoT gateway. So the OSGI interworking, the basic concept of OSGI interworking is try to interworking the services from the OSGI-based gateway to OneMTerm infrastructure. So by this way, the applications of OneMTerm can access the services provided by this OSGI gateway and vice versa. So what we are doing is that we have created work item in OneMTerm to define interworking, and we have created an RFC in OSGI, basically define the same standards. And then we contribute some code into Eclipse OMTerm, like what shown in the red rectangle of the OSGI interworking service that can connect for example, the services from Eclipse Smart Home, the services from Eclipse Kura to OneMTerm resources, so that the two systems can be working together. So in this way, we are binding the three organizations together: the OneMTerm, the OSGI, and the Eclipse, which makes the three ecosystems be combined using the one single technology, so that the ecosystem can be shared between three communities, which is greatly broaden the collaboration area. If we go to another layer down of how this is done, so basically this is the OSGI framework. It provides the framework for the plug and play of the bundles, for the discovery and registration of the services. In the Eclipse OMTerm project, where we have the CSE bundle, which hosts all of the OneMTerm defined resources. What we have done is that we developed OneMTerm OSGI IPE bundle, which is doing the transformation from the services that is defined by OSGI, for example, the OSGI device abstraction layer service. So once the OneMTerm OSGI IPE bundle discovers the registration of the other OSGI services from the framework, this bundle will make the interworking and changes that service to the context of OneMTerm resources. Then this makes those services exposable by the OneMTerm defined MCA reference point by accessing the OneMTerm resources. So this is basically how this is done in the architectural level. So basically, I have introduced all I have from here. So this is, I have to say, this is just a beginning of how this interworking can be done. So the OSGI interworking is the start of bringing the two ecosystems together. We also are working on the other interworkings, like in the OPC UE, for example, the DDS. And then we are also defining a framework that's how to interwork the proprietary devices into the single architecture. We have a demo booth right outside of this meeting room. It's demo booth 5. We have a live demo on how to connect a fan that is OSGI compliant by accessing the OneMTerm resources. And we also have a little gift from China. This is called the Chinese knot. It's a very traditional Chinese way of gift. It represents happiness, fulfillment, and best hope for the future. Okay, so thank you. If you have any questions. Okay, thank you. So welcome to our booth.